Hey guys, I'm back. Again, I just don't want the video to get cut off. I want to be able to do these all together. So if you're going to solve a trig equation that has a period change, we still, in this section, only want to find angles between 0 and 2 pi. So they're still going to restrict it to a certain number of angles that you're allowed to say are answers. You don't have to, say that there's infinitely many answers, even though there are. They're restricting it to just angles between 0 and 2 pi who make these equations true. But again, if something happened to x, then something happened to that period, and that could affect the number of answers that we have. So I always call it we have to prepare for more answers, okay? All right, so here we go. So if we have to solve this. Now, you're going to want to get this 2 away from theta eventually, right? But he's stuck inside the function. So you basically can't worry about this 2 until you've solved the problem, if you will. So in the beginning, just picture that this says sine theta. All right, forget the 2 theta. Just picture that it said sine theta like the other ones. Don't worry about it yet. Our job is to get this by itself. So divide by 2. You know what? I want to do this over here because it's going to get pretty long. 2 sine 2 theta equals 1. Okay, so divide by 2. Get sine 2 theta by itself. And you end up with the sine of 2 times theta equals 1/2. Okay, so again, right now, forget that 2. Just pretend it said sine theta equals 1/2 and solve it like you normally would have, right? Okay, so the sine of theta had to equal 1/2, right? Okay, well, the sine of an angle equal a positive ratio. That means, according to all students take calculus, the angle must have been in quadrant 1 or quadrant 2, right? Because that's where the sign is positive, all students. All right, so now what angles would have made this true? The sine of what special angle would have been 1/2? 30, 60, 45, it's a 30, right? So that's a pi over 6. That's a multiple of pi over 6 in quadrant 1 that makes this true, and that's a multiple of pi over 6 in quadrant 2 that makes this true. Well, what pi over 6 is that? Well, if this is 6 pi over 6, then that is 5 pi over 6. Okay, so if this had just been sine theta equals 1/2, those would have been your answers. It would have been pi over 6 and 5 pi over 6, but it's not. It's 2 times theta that has to equal this angle and this angle. So that's what we have to do. So now, once you find the angles that would have made this true, set 2 theta equal to those angles. What's going to make 2 theta equal these angles? So the way I do it is 2 theta could have equaled pi over 6 plus, here's the thing, there's a period change. So there could be more or less answers to this problem in a 0 to 2 pi interval now because you've changed the period. So now we want to prepare for more answers. So add the original period, what's the original period of sine, 2 pi onto this. We are preparing for more answers, okay? Because the period has been changed, there might be more or less answers from 0 to 2 pi. So we're preparing for it by adding the original period on, okay? Or 2 theta could have equaled, what was the other angle we said makes this true? 5 pi over 6 plus 2 pi radians away from him, right? Prepare for more answers. So add that original period on. All right, well, here's the problem. So 2 times theta has to equal this plus that period. Now you solve this for theta. Now, what real angles make this equation true? Remember, pi over 6 and 5 pi over 6 only would have been the actual answer had this just been sine theta. But because it's 2 times theta, the angle has been affected. So now we have to solve this for theta. That's what I mean. So you're really not going to use this until you've actually fake solved the equation. All right, so now in order to get theta by itself, I would divide by 2. But I think it's easier if I just times both sides by 1/2. So they is gone and theta is by itself. But now I have to times this entire side by 1/2, right? So I'm having pencil trouble. So now 1/2 times pi over 6 is pi over 12. So that's the first real answer that would have made this equation true because of that period change that had happened. All right, plus now 1/2 times 2 pi, the new period is only pi radians. So now the next answer will only be the new period away, which is pi radians, okay? And we'll come back to that. All right, now let's solve this one. So solve this one for theta. So times both sides by 1/2, times this whole side by 1/2, and you're going to get 5 pi theta equals 5 pi over 12 plus, if there are more answers, they'll only be a period away, and now your new period is pi radians because of that period change. Okay, so these are the first two real angle answers to this equation because of that 2 sine theta. So now we want to find all of the other angles that are in between 0 and 2 pi, right? All the angles have to be in between that complete rotation. So now there might be more answers because by changing the period, you might have affected the number of sine waves that occur from 0 to 2 pi, okay? So now all you have to do is take your first answer, pi over 12. Ooh, I'm having pencil trouble today, guys. Pi over 12. And now we're gonna start adding the period to him until we get beyond 2 pi radians. So remember, technically right now, angles that are answers are multiples of pi over 12. So in the world of pi over 12, how many of them make 2 pi? 24. So as long as your angle is 24 pi over 12 radians or smaller, it's an answer to this problem. So as long as you're not circling angles that are bigger than 24 pi's over 12, they're answers. All right, so here we go. Let's add the period to him. So pi over 12 is my first answer, and now I'm going to add the period, plus pi, which I hope you all agree to make a common denominator. That's really 12 pi's over 12. All right, so 1 pi over 12 plus 12 pi over 12, 13 pi over 12. Oh my God, my pencil. 13 pi over 12 is an answer as well, because 13 pi over 12 is less than 24 pi over 12, which means he's within that 0 to 2 pi interval. All right, add another one. Now add the period to him. Add 12 pi over 12 to him, and you get 25 pi over 12. Well, isn't 25 pi over 12 bigger than 24 pi over 12? So that means he's not within between that 0 to 2 pi interval. So he can't be an answer because he's beyond 2 pi radians. So right now you have 2 angles that make this equation true. Okay, now take the other one and do the same thing to him. Let's start adding the period to that angle to see if we can get more angles based off of him. So now we take 5 pi over 12, which is an answer. So circle him. And now let's start adding the period to him until we get beyond 24 pi's over 12. So add pi to him, which again is really 12 pi over 12. And then you're going to get 5 pi over 12 plus 12 pi over 12 is 17 pi's over 12, which is less than 24 pi over 12. So he is within that 0 to 2 pi window. All right, so he's an answer too. So now add the period to him. Keep adding that period until you get beyond 24 pi's over 12. Well, guys, if I take 17 pi's over 12 and add 12 pi over 12, that's 29 pi's over 12, which is definitely bigger than 24 pi's over 12. So he's an answer, but he's not within that 0 to 2 pi restriction they gave us. So that means that this equation has 4 answers. 1, 2, 3, 4 angles between 0 and 2 pi that will make this equation true. All right, so by changing something inside, it affects the number of answers, and you have to use that period to prepare for more. Okay, so this will get easier as you practice it a little bit more and more. Let's try another one. Okay, so look at the next question. Solve for all theta between 0 and 2 pi that make this equation true. The secant of 3 times theta over 2 equals negative 2. So again, they've clearly done something to theta, which means they have done something to x, which means they could have changed the period. So we're going to have to prepare for that period change and how it might change our answers and how many answers there are. All right, so let me write this one down. The secant of, where am I? Oh, 3 theta over 2 has to equal negative 2. Okay. Well, like before I said, don't worry about this 3 times theta over 2. We really don't use him until we've kind of like, I call it fake solved the problem. Just think of this as secant theta equals negative 2. Well, truthfully, if this was secant theta equaled negative 2, I don't want to work with the secant. I want to work with his original reciprocal trig function, which is the cosine. So if the secant of this angle equaled that ratio, then the cosine of that same angle would have equaled his reciprocal ratio, which is -1/2. And now we're in business, all right? Okay, so let's work the quadrants. All students take calculus, right? All right, so if the cosine of some angle equaled a negative ratio, then we know all students take calculus. All calculus means this is where the cosine would have gotten you a positive ratio. So if the ratio was negative, it must have been a quadrant 2 or a quadrant 3 angle. Okay, well, what kind of angle? Is it a 30, a 45, or a 60? Do you remember the cosine of what special angle got you 1/2? Well, remember, the sine of a 30 was 1/2, so that means the cosine of a 60 is 1/2. It must be some multiple of a 60, some multiple of a pi over 3. So you have some multiple of a pi over 3 in each one of these quadrants. Well, what multiple of pi over 3 is that? Well, remember, if this is pi, which is 3 pi over 3, then this is 2 pi over 3, and this is 4 pi over 3, right? Okay, so now, but remember, these would have only been the answers had that just been theta. Cosine theta equals -1/2. Those would have been the answers. But it's not just the cosine of theta, it's 3 times theta over 2. So it's 3 times theta over 2 that has to equal this angle. It's 3 times theta over 2 that has to equal that answer. So that's how we have to set this up. So 3 times theta over 2 has to equal 2 pi over 3 plus, let's prepare for more answers because of that period change. So now add on the period of cosine plus 2 pi radians away. Could be more answers, okay? All right, or 3 theta over 2 could have equaled 4 pi over 3 was another one of our fake answers, if you will. Plus, prepare for more answers, add the period to that. Okay, so now we have to solve, all right, so what are the real theta that make this true? So get theta by itself. So to do that, times by the reciprocal, times by 2/3. And then times all of this by 2/3. So really, theta has to be 2/3 times 2 pi over 3 is 4 pi over 9. Plus, here's your new period. 2/3 times 2 pi, if you throw him over 1, that's 4 pi over 3. 4 pi over 3 would have been the period of this transformed function. All right? So really, this would have been like how to get all the answers. We only have to find the ones in between 0 and 2 pi. All right, let's do the same thing over here. So solve for theta by timesing by 2/3. All right, times by 2/3, and then theta could have equaled, now we're about to get our first real answer again, 2/3 times 4 pi over 3 is 8 pi over 9, plus now 2/3 times 2 pi is 4 pi over 3. That's your new period that you're gonna have to add on to these answers that are angles that are now answers. Oh, I don't think I was on the screen there, guys. Sorry. I just times by 2/3 here, and then I times by 2/3 here. I got 8 pi over 9 plus 4 pi over 3. Okay, so here we go. So we have to find all the angles that make this true in between 0 and 2 pi. So if you notice, our fake answers were 2 pi over 3 and 4 pi over 3. My first real answer is 4 pi over 9, and my second real answer is 8 pi over 9. So we're working in the world of pi's over 9. So if all the way around is 2 pi radians, well then in the world of pi's over 9, that's 18 pi's over 9. So as long as our answers stay under 18 pi's over 9, they'll make this equation true. They will be in that interval from 0 to 2 pi. All right, so all we're going to do is take this answer and start adding his period until we get beyond 18 pi over 9 radians. All right, so take 4 pi over 9, your first answer. Circle him because he is your first answer. And now let's start adding the period to him to get more answers. All right, so 4 pi over 3. So I got to get a common denominator of 9. So times by 3, that's going to be 12 pi's over 9 is what you're really adding to it. So 4 pi over 9 plus 12 pi over 9 is 16 pi's over 9. 16 pi's over 9 is less than 18 pi's over 9, so he's an answer. All right, if you keep adding, add another period to him. Add another 4 pi over 3, which is 12 pi over 9, and you're going to get 28 pi's over 9. 28 pies over 9 is definitely past 18 pies over 9, so he's not in between 0 and 2 pi, so he can't be an answer. All right, so we're done. So now we go here. Let's try and go, what other angles can we get based off of this one? So now 8 pi over 9 is another answer. And now add the period to him until you get beyond your 18 pies over 9. So add your 4 pi over 3, which I said is really 12 pies over 9 when you get a common denominator. And what happens is 8 pies over 9 plus 12 pies over 9 is 20 pies over 9, which is already past 18 pies over 9. So he's not an answer. So in this problem, you only end up with 1, 2, 3 answers that could make this equation true. The next answer that's a period away from him is beyond the 2 pi. So you only end up with those 3 answers. I know it's a little bit weird, but that's what you have to do. You have to prepare for more answers using that original period, okay? All right, let's keep going. Let's try another one. So now, look at this one. We have to solve this one. 5 tangent 3 theta equals negative 5 root 3. Let me write it down because, like I said, these ones take a little bit more room. 5 tangent 3 theta equals negative 5 root 3. Okay, well again, tangent 3 theta. We can't even talk about that 3 until we've already, like I say, fake solved the problem. So don't worry about it. At least get the tangent of 3 theta by itself by dividing by 5. All right, so now the tangent of 3 theta has to equal negative root 3. Okay, so let's work our quadrants here. All right, so all students take calculus, right? All students take calculus. That means the tangent is positive ratio in 1 and 3. All take, right? So then if the tangent of some angle is a negative ratio, we know that angle had to be in quadrant 2 or in quadrant 4 because that's where the tangent ratio is negative. All right, well, now, does anybody know what angle it is? The tangent of what special angle? 30, 60, 45. Who was root 3? It's a 60. And again, that should come from memorizing. Otherwise, you can draw a right triangle and work your special ratio side lengths. All right, but I know it's going to be some version of a 60. So that's a pi over 3 here and a pi over 3 here. Well, what multiple of pi over 3 is this? Well, in the world of 3 pi over 3, that's 2 pi over 3. If this is 2 pi all the way around, then how many pi's over 3 get you all the way around? That's 6 of them, right? So that would be 5 pi over 3. So the two fake answers are 2 pi over 3 and 5 pi over 3. But remember, those would have been the angles that made this equation true had it just been theta. But it's not just theta, it's 3 times theta. So in reality, it's 3 theta who has to equal 2 pi over 3 plus add on the period to prepare for more answers. Now remember, the original period of tangent was only pi. Okay, all right, and now it's 3 theta. He could have equaled 5 pi over 3, and now prepare for more answers again and add on that period of pi. All right, so again, now we're going to officially solve for theta. So remember, if you did 3 times theta, you definitely affected that period. And this is how we'll find out what that new period is. This kind of takes into account there. All right, so let's divide both sides by 3. I'm going to times by 1/3 to make it easier. Times this by 1/3, and I end up with theta equals, here's my first answer. My first real answer is 2 pi over 9. Plus, if I'm going to have more answers, they're going to be a new period away, which is 1/3 times pi is pi over 3, because pi over 3 is really the period of this transformed tangent function, okay? I do the same thing over here. Let's solve for theta. Times by 1/3 times by 1/3. And you would have gotten theta equals 5 pi over 9 plus pi over 3, which is your new period. Now, I don't mean to spoil it, but the good thing about tangent is because this period is shorter, it's half the period of sine and cosine. It's only pi radians, not 2 pi. You get a lot of overlapping of answers where once you start adding the period to your first angle, he actually picks up all the angles that he would have picked up too. There's a lot of overlap. So you should only have to do this once. All right, so here we go. So if we're working in pi's over 9, then again, in the world of 2 pi, how many pi's over 9 make 2 pi? 18. So once we get past 18 pi's over 9, we're going to be outside of that interval, and those angles won't be answers. All right, so here we go. Take your first answer, which is 2 pi. You know what? Let me back up. Let me give myself room here. Take your first angle, which is 2 pi over 9. Circle him because he is an answer. And now let's start adding that period onto him to find more answers. So if I add on pi over 3, which, guys, common denominator times by 3 is 3 pi over 9. Here we go. Ready? So start adding the period. 2 pi over 9 plus 3 pi over 9 is 5 pi over 9, which, guys, we already found that answer. So this is what I mean. You're only going to have to add the period to your first angle, and then because of his shorter period, it'll pick up all the angles that he would have landed on anyway. There's a lot of overlap. All right, so you only have to do it to this one. So now add the period onto him. Add 3 pi over 9 to him, and you get 8 pi over 9. Well, I'm still below 18, so keep adding it. Add another one onto him. 3 pi over 9, and now I have 11 pi's over 9. Well, he's smaller than 18 pi over 9, so he's an answer too. All right, now add another one on. Add 3 pi over 9 onto him, and you end up with 14 pi's over 9. So he's under 18 pi over 9, so hang on to him. He's an answer. All right, add another period onto him, plus 3 pi over 9. That's 17 pi over 9. Oh, I don't like the way I wrote that. That's 17 pi over 9. So he's an answer because he's under 18 pi over 9. And now I hope you would all agree that if I added on another period, another 3 pi over 9, I would be at 20 pi's over 9, which is definitely not smaller than 18, so he's outside the window. So these are all your answers that are going to make this one true, because what you've essentially done is you have shrunk the period to pi over 3. So now 3 times as many tangent curves fit in that 0 to 2 pi window. All right, so you've created like triple the answers, if you will. So you get 1, 2, 3, 4, 5, 6 angles that will make this equation true. Okay, all right, last one. The last one doesn't necessarily have a period change, but again, you've definitely done something to the inside, and you're not going to be able to get to that until you like fake solve the problem. All right, so just bear with me. This is a phase shift. This moved the graph right or left, which again could have affected the number of angles that landed between 0 and 2 pi that are answers. All right, so let's just solve it. The tangent of theta minus pi over 2 equals 1. Okay, so first things first, you still would have gotten the tangent of all of this by itself, but it's already by itself. There's nothing to move away on the outside. So just pretend this just said tangent theta equaled 1. Okay, if it just said tangent theta equals 1, well then what angles could have made that true, right? All right, well, if the tangent of an angle equal to positive ratio, all students take calculus, it would have been an angle in quadrant 1 or an angle in quadrant 3, because that's where the tangent of an angle gets you a positive ratio, right? All right, so now, do you remember the tangent of what special angle? 30, 45, 60, who had a tangent of 1? It was a 45, a pi over 4. So it's some multiple of pi over 4 in quadrant 1, and it's some multiple of pi over 4 in quadrant 3. Well, what angles are they really? Well, in quadrant 1, pi over 4 is pi over 4. But what multiple of pi over 4 landed in quadrant 3? Well, again, in the world of pi's over 4, this is pi, which is 4 pi's over 4. So the one that came right after it is 5 pi's over 4. Okay. So these are your two fake answers to this equation, right? But it's not really theta who has to make this equation true. It's theta minus pi over 2. So it's theta minus pi over 2 who had to equal pi over 4. And again, there could be more or less answers. So add on that period of tangent, which is pi, to kind of prepare for more or less answers, if you will, okay? And then the same thing, theta minus pi over 2 could have equaled the other answer, 5 pi over 4, plus add on that period of the tangent, which is pi, to prepare for more answers. Okay, well, we have to solve this for theta. What actual theta makes this true? So all you have to do is add pi over 2 over. Now, if this was an equation, let's say 10x plus 4 equals, let's just pretend it's 12 plus, I don't know, 6, just for whatever reason. If I wanted to solve this for x, well, we definitely would have combined them to make 18, but let's just say you didn't. If you minused 4 to the other side, you would not have minused 4 to both of these numbers. You would have just minused 4 from one of them. You would have picked one and minused 4 from it. So when you add pi over 2 over, you don't add it to the angle and the period, you only add it to 1. So just add it to the angle, not the period. All right, so add pi over 2. And then you end up with theta really ends up equaling, well, what's pi over 4 plus pi over 2? Get a common denominator, and that's going to be 2 pi over 4, if you times by 2. And that's actually 1 pi over 4 plus 2 pi over 4. That's 3 pi over 4 plus his period never changed, because that wouldn't have changed the period. That would have just moved it right or left. The period still would have stayed the same, so it shouldn't affect the original period. Okay, so we're still going to add pi onto that to get that last answer. Okay, now let's come over here. So add pi over 2 here to the angle, not the period, and you end up with theta equals, well, again, this is really 2 pi's over 4. So 5 pi over 4 plus 2 pi over 4 is 7 pi over 4 plus that period still. And that's how we're going to get all of our actual answers. All right, here we go. So we want all of the answers between 0 and 2 pi who make this true, right? Well, remember, if we're dealing with 2 pi, and we're working with pi's over 4, well, then how many pi's over 4 make 2 pi? 8. So as long as we stay under 8 pi's over 4, we can keep them as an answer. All right, so here we go. And again, the beautiful thing about the tangent function is there's a lot of overlap. We really should only have to add it to this one, and then he would have picked up all the angles that he would have gotten as well because of that shorter period. All right, so take the first one, 3 pi over 4. Let's start adding the period of pi to him. Circle him so you know he's an answer. All right, so plus pi, which again is 4 pi over 4, and that equals 7 pi over 4, which is that answer that we already knew, and it's also less than 8 pi over 4, so we're going to keep him as an answer. Now, add on another period, add on another 4 pi over 4, and you get 11 pi over 4, which is definitely bigger than 8 pi over 4, so it's not an answer. So really, the only angles that are going to make this equation true are 3 pi over 4 and 7 pi over 4, and you're done. Okay? All right, I know that's a lot to take in, so if you have any questions, please text me, and I would be more than happy to help you through any of these problems. Otherwise, good luck, and like I said, I don't advise using a calculator, but you can always use the calculator to at least get you that reference angle. Was it a 30, a 45, or a 60? In that way, it should at least help you. All right, well, good luck. And again, reach out to me with any questions.